Alright, ladies and gentlemen, so today we are going to be talking about adding and subtracting radicals. So, when we're talking about adding and subtracting radicals, we're looking at a problem that kind of looks like this. Alright? And at first glance, you might be looking at this and going, well, Mr. Harrington, I have no idea how I could possibly do this. But, if you stop for a second and think about it as if we were combining like terms, alright? Think of these radicals as if, what if I told you that this is 3x and this is plus 8, we'll say the square root of 3 is y, and we'll say we've got plus 2, look over here, square root of 2, x, well then this must be an x. Well, if we think about this, think back to when we were talking about combining like terms, this should become pretty obvious. 3x and 2x, combine those, you get 5x. The 8y has no like term, so that's just plus 8y. Well, if we go up, we think of these as radicals. Think of these radicals just the exact same way as if we were talking about the variables. I think we just be like, all right, where do I see like radicals? Square root of 2 here. Go over and I see square root of 2 here. 3 square root of 2 plus 2 square root of 2. That's 5 times the square root of 2. Square root of 3 does not have a like radical to go with it, so that just becomes plus 8 times the square root of 3. Now we look at these and we look and we say, well, square root of 2, square root of 3, those aren't the same, so they can't go together. So just like 5x plus 8y is as simple as it gets, 5 times the square root of 2 plus 8 times the square root of 3 is as simple as it gets, and we're done. All right, see? Not super difficult. Now, we can do the exact same thing when we're talking about subtraction. All right? So look at this problem. 6 times the square root of 7 plus 4 times the square root of 13 minus 5 times the square root of 7. Take a look at this for a second. See, do I have any like radicals? Well, right here, square root of 7. Right here, square root of 7. Those are like radicals. Look at their coefficients. I've got 6 minus 5. That's just 1. So that's just square root of 7. Square root of 13. Not here. Not here. So this is just minus 4 times the square root of 13. And you're done. There is nothing else that can be done to simplify this. All right? So you're probably thinking now, well, Mr. Harrington, this is not super hard. Why are we wasting all this time talking about it? Well, we go into a problem that looks like this. Now you look at this problem, and you think about what I just have shown you. All right? Got to have like radicals to combine these. You look at these, you say, well, hey, that's square root of 32, that's square root of 98. Those aren't like radicals. I can't do anything to this. Well, that's where you'd make a mistake. All right? If we think about this, this is not a simplified radical. All right? Think about what we've been talking about in class the other day, next couple days. Square root of 32, not a perfect square. But we can think, what is a perfect square that goes into 32? Well, if you think about this for a second, you'll find if I do 32 divided by 2, I get this is the square root of 16 times 2. All right, we can take the same idea over here. Square root of 98. If I do 98 divided by 2, I get 49 times 2. All right, well, think to simplifying radicals. This works out to the square root of 16 times the square root of 2. Square root of 16 is 4. So this is 4 square root of 2. Square root of 2 does not simplify. Over here, this works out to 49, or square root of 49 times the square root of 2. Think about this. Square root of 49 is 7. Once again, square root of 2 does not reduce. Well, now look at that. I've got 4 square root of 2 over here. 7 square root of 2 over here. We're looking for like radicals, and we see that and that are both square root of 2. They're like radicals, so they can be added together. 4 plus 7 is 11. So your answer ends up being 11 times the square root of 2. And that's a simplified version. So this is the sort of problem we're going to be talking about a lot in class tomorrow. It's the sort of problem you're going to see on a test. You need to make sure that before you add or subtract, you first simplify the radicals. All right? So let's do one last problem together. Maybe. All right. So we're going to take a look at this for a second. Square root of 243 minus the square root of 75. All right. So taking a look at this one. Once again, we have unsimplified radicals, and we need to try and figure out what is the simplest version. Well, taking a look at this, we've got 243. What could possibly go in to 243? Think about this for a second. 2 isn't a factor. Maybe 3 is a factor. Well, if we work that out, we can find out that this ends up being, if I factor out a 3, 243 divided by 3 is 81. So this is 81 times the square root of 3. And 81 is a perfect square. All right? So that's good. That's what we're looking for. 75, well, if our perfect square is 81 times the square root of 3, you know square root of 3, or you know 3 is going to be what we leave underneath the radical. So maybe we want to see, can 75 be divided by 3? Turns out, 75 divided by 3 is 25 times 3. Take a look at this. This is what we want to see. We want to see the same number under the radical. Okay? We keep working. We can now separate these. Okay, we could separate these so that we get the square root of 81 times the square root of 3 minus the square root of 25 times the square root of 3. Simplify. Square root of 81 is 9. Square root of 3 we don't know, so that just stays square root of 3. Over here, square root of 25 is 5. Once again, square root of 3 stays square root of 3. Now, have like radicals, don't we? So now we can combine these. 9 minus 5 is 4. And that's times the square root of 3. So, now you know how to add and subtract radicals. First simplify them as far as they can go, then combine all of the terms that have like radicals. So right now you need to go do the try it problem, and tomorrow we'll talk about this more in class.